All range personnel be advised, rocket charges are armed. GSE, confirm ground side status.
GSE is locked.
Flight ops status check. Return go or no go for launch.
Fido is go.
OSM is go.
OSO range is green.
Go flight.
All flight and range ops are go, locking in for terminal count.
Hello, it's Joey B. Uh-oh, hold on. Wait, the sound is still on my laptop. Hello, it's Joey. We're off to a real solid start here, folks. My name is Joe Barnard. Welcome to my channel called BPS.space. Let me pop out the chat here and we will get started. Today, we're going to be doing some maintenance on the Launchpad. We just had the flight test of the Falcon Heavy boosters, which you can actually see back there on the table. We might take those out and do a little explanation of how some of that works. But anyway, we have a Launchpad to convert from a 3-core setup to a 2-core setup, right? So you have to sort of modify the pad in between launches. And the next set of tests that we're going to be doing are on the second stage for the Falcon 9/Heavy. And actually, well, I'll get it later. It's sitting over there. But we've got a second stage to launch, and we can't do it with the 3-core setup, and I'll explain why right now as I switch to the workbench camera. Hello! Check out this fisheye, by the way. Isn't this kind of cool? I got a whole fisheye camera on the lens. Or fisheye lens on the camera. Oh boy. Alright, let's read some comments. Johnny's in here. Hi, Johnny. Who else? I read back a little bit. I know we've got Jared, we got Chase, we got Lionel Owlette, we got Arsenio. Arsenio is the mod. Thank you, Arsenio. We got Mr. Steven. Thank you for the work you do with the fairings, sir. We've got William. We got Katie Sodden. Alex. Jcraft. All right, well, we're not going to read all the names. Actually, I think those are most of them anyway. Oh, Dave Insanity. Folks, this is the Launchpad. This is the... My goodness. My words are so good. This is the Launchpad, and this is how it was set up for the Falcon Heavy test flight. So we'll just explain it real quick here. We've got our, these are the 2 inlets for the outlets here, which is where all the fire comes out. So when it lifts off the pad, it goes, right, like that. So the smoke is coming in here. Since we didn't light the center booster, we didn't need anything here. And actually, maybe we'll play some footage later. I stuck a camera in here at launch pointing upward. So we have this crazy shot and sound from a camera right in the center thing when the Falcon Heavy takes off. Anyway, so that's kind of cool. This is the Launchpad computer. I'll turn it on for a second. We're actually, the computer, the Falcon Heavy really did a number on the computer. The Impulse computer is nearing the end of its life cycle. We have an update that's coming to the computer soon. But anyway, basically, it's on its last legs. It's having trouble detecting when we're actually triggering launch, which is obviously no good for a Launchpad computer. I'll start it up here. Yeah, so it automatically goes into the countdown now. But anyway, you can sort of see how that works. At 2 seconds, the clamps release, and then that's ignition. So it's just a 10-second count right now, but maybe we'll go through the software at some point. You can sort of configure what sort of settings you want in terms of countdown time, hold down time, igniter up time. Actually, a lot of the stuff is similar to how configurable Signal is, with obviously the goal of commercializing this stuff. Anyway, I've missed a bunch of chat. Let's go back and check it out. Water hose. Everyone's memeing me for the fisheye camera. All right. Hey, Austin. Hey, Laurent. Chase. Did Elon contact me? No, he did like the tweet, but he did not contact me. New PCB. Great job with the launch. Hey, thanks, Aaron. Why do you think it started incorrectly identifying the launch trigger? So, you want to get into it? Are we going there? We can do it if you want. Hello from Texas. Hi, Jack. I'm rebuilding my Aspire, ready to take it. Message redacted. Never mind. Get into it, says Mr. Steven. Let's do it. So the deal, actually, let's be safe. Let's unplug the lithium polymer battery before we put lots of metal near it. So this is the computer. This is the Impulse launch computer. There's a lot of things connected. There's a lot of outputs here. This is like, I don't know if you can see this on the camera. Let's see. Will it? Nope, that's the wrong direction. It is gonna work, but the fisheye makes it a little tricky. Okay, so this is like perhaps the worst thing that I've ever seen in my entire life. Just bodge out the wazoo. But on the bottom, Johnny was asking about why doesn't this thing work, right? Why doesn't the launch detection work? You can kind of see right here, I've already started bridging resistors. So there's a continuity detection circuit that happens right here. And so I think it's 5 volts is sent down one of these green wires. This is the launch trigger, or really it's the countdown trigger. 5 volts is sent down one of these wires, and then it. Oh wait, how does this work? We're just detecting continuity. It actually, whatever. The circuit is decaying, as is the processor and the analog channel. When I say that the Falcon Heavy really did a number on the Launchpad when it launched, what ends up happening is there are little MOSFETs that sometimes, depending on where the leads of the wires fall in here, will short out. And if those MOSFETs short out, they blew smoke everywhere, and then you have to replace them. So the next iteration of the Launchpad, sort of ironically, I think we're going to move back to a relay-based setup, where there are physical, mechanical relays to light the igniter, so they are entirely decoupled. We might even do relay to optocoupler instead of MOSFETs to trigger. Anyway, whatever. This is more than we need to get into today, and I'm sure we can do another live stream that talks about Launchpad PCB design. However, what we're doing today is we're going to move these launch clamps, right? So for a single core setup, For a single core setup, we've got, well, what is it, 3 cores? 1, 2, 3, 4, 5, 6, 7, 8 launch clamps. They all open and close, like we showed before. Right? And all we need for the single core setup is 1, 2, 3, 4. And then what we do here is, if you look closely, there are holes in the launch pad for these clamps to actually just scoot inward. So SpaceX, what they do with pad 39A, where the Falcon Heavy and the Falcon 9 launched from, they, I think, remove these two. You know what? I am making this up. I don't know if they remove these two or if they just scoot these guys in. I know it's a pretty simple conversion, though. Anyway, it's kind of close to that, though. Oh, man. I'm getting behind. Is that a default drill? Plans on setting up a commercial pad computer one day. Yes, Chase, indeed I am. But lots of development is still needed. Actually, not that much. Pad computers are pretty simple. But I have a ton of outputs here with the idea that this is a super customizable setup. Johnny says, oh, I see, you realize where it's at. This is similar to how my MRC works. This is our... Oh, solid-state relays are good, too. It's beautiful. Hello, everyone. Pad computers are pretty simple. All right, let's get started. Actually, would anyone like to see the bottom of the Launchpad? This is kind of where the nightmare begins. Raise your hand. Well, don't raise your hand. If your name is Arsenio, or if your name is Johnny, or if you have any self-respect in terms of wiring and cable management, what I want you to do is I want you to take your hand, both hands like this, and it's this tricky maneuver where you're just going to go like that, okay? You're going to go like that, and make sure your hands stay there and that they don't move, okay? All right, here we go. Oh. So, check it out. It's bad. They are all over the place. Don't do this. And then they're all secured with hot glue. The thing that is the neatest, like the most organized on the bottom of this pad, are the cables that run lighting on the sides, right? These indicator lights, the red and white indicator lights. It's not that bad. Joe, you must learn the way of the zip tie. I think I have zip ties here somewhere. Oh, you know what? No, I don't. It's all hot glue. This is just atrocious. So anyway, what we're going to do, as I've said several times, just incompletely, is we need to modify the flame trench just a little bit. So this plug is going to get unplugged. There we go. I'm going to open this up. So this is for the center core, if you were going to launch a center core enabled Falcon Heavy. But there's a bunch of soot in there. I wonder, we might change the lens on the camera. This is a little bit... no, it looks fine. Hot glue for life. Okay, so, yeah, actually, the way we have to start doing this, I'm trying to remember how I did it before. The way we have to start is we need to loosen the flame trench U-bolts. So these U-bolts hold the flame trench against the launch pad. So let's go ahead and do that. All right, so we're gonna start in the middle and then work our way out. So this is what, if you've ever seen this, which, I mean, you're watching it on YouTube, these 4 U-bolts are what hold the flame trench to the launch pad. And it's actually, it's really tight, like it's really well on there. And then all you have to do to either remove, eventually this will need to be replaced. It's iron and it oxidizes like crazy. So it will have to be replaced, which is why you can easily do that with these. I'm gonna unscrew this a little bit, and this one too. Oh, it's Ben! Hi, Ben. Welcome, Ben. Everyone, please type in the chat. Use your keyboards, use your hands, use all your appendages to type "Hi, Ben" in the chat. Okay, here we go. We're going to do the middle 2 first. The order doesn't really matter for these. Still pretty tight. You can see like the side ones hold it on pretty well. These are the only ones that are tightened now. And I think the whole pad is probably like 10 pounds. It's really, it's pretty beefy. I went with, I'm trying to remember what kind of wood I used, but it's mostly wood. The paint on top is a really high heat resistant paint. It's like stuff that you would use on a grill. And I don't think that matters too much. Like, it's still wood, but yeah, I don't know. Hi Ben, hi Ben, hi Ben, Cars 2. Okay, Chase. All right, we got a loose flame trench, folks. Let's knock this one out here. Oh, we still need to loosen it a little bit more. Falcon 1E is here. Hello, Falcon 1E. Quick question, what kind of adhesive do you use to build your rockets? Epoxy, super glue. Super glue. Wow, I am just having a stroke. 1 second, let me show you. I love this stuff. I'm not sponsored by them. I would accept a sponsorship from it though. Zap a Gap, right? Zap a Gap, medium CA plus, gap filling formula, whatever. I don't have to read you the bottle, but that stuff's great. It's not viscous, so like I still use traditional epoxy like Gorilla Glue and stuff like that for really serious applications. So all the glue surrounding building the ejection charge and parachute stuff, like all the glue that is involved in that process is 2-part epoxy, because that's just super strong stuff. However, for things that are like quick glue jobs, here we go, there it is. Quick glue jobs, this is great. And it's really fast too. It's like super glue. Loose flame trench, TFT is always loose. How Elon types the letter A lands. Joe, who is my lube supplier? You know what? You make the memes about the lube, Ben, but I'll tell you what. If you want your 3D printer to run as smoothly as possible, Super Lube is the way to go. And you only need a little bit. Okay. Moving on, ladies and gentlemen. Let's turn the pad upside down once more. Okay. So now the flame trench is... we can modify it. So let's unscrew these inlets and we're going to plug those back up. Right? So you can sort of see inside now. Not that there's like anything super interesting to see inside of the flame trench, but if I move it, you can see it's nasty in there. You don't want to be there when the clock hits 0. That is the wrong place to be. Okay, so I've got these inlets. This one, I mean, they all look bad. I'm trying to think of which one is, I don't know, this is probably fine. They're all about the same. Anyway, yeah, but I'll have to replace this whole flame trench probably in 4 or 5 more launches. Maybe less. I can probably afford to go with less, but just because it's iron, it rusts like crazy. Okay, and then we need 2 plugs, one here and one here. Let me go grab those. Probably could have prepared for this a little bit better, but I don't know what to tell you. Here we are. Okay. Great. Is the Android app for Signal R2 almost done? That's an excellent question. I wonder, there's a gentleman named Andy, who I know, who might be watching now. And Andy, I would love to know what the status of the... Sorry. It's almost done, yeah. It's actually doing pretty well. We did a lot of good communication tests with it the other day, and it might still be a little bit behind the iPhone app in terms of when it gets released. The iPhone app is getting submitted to the Apple Store this week, but the Android app it's chugging along, and it will work. And if you really need to, you can use Signal without an app. It just is really helpful to use the app. Okay. There's nothing interesting to see in the flame trench. Sorry, Ben. FYI, avoid galvanic steel if you're looking for a replacement. When burned, the fumes are toxic. Good to know. I always overdo the super glue. I've used a whole tube today. Oh my gosh. It must just be like all over your hands. Why not paint it as well with the heat black paint? Because I don't care that much about it. And it used to be black. Like it used to be, you see the color right here under the U-bolt? This kind of reflects it too. It used to be a shiny black color, but it just rusts. Next time you replace the flame trench, why don't you coat it outside in Rust-Oleum? Will that really help? Is that really a rust thing? I thought it was just like the name of the paint. I think you stole and Falcon 9 technology. I don't know what that means. powder. All right. So anyway, we've got the Launchpad plugged. It feels pretty solid. Now it's time to tighten up the U-bolts again. Now this part is a little bit trickier because it's still loose. I might try to tighten it from the other side first, just to give it so it doesn't like slop down a whole bunch. IDK, but I think it does stop the rust. Let me see real quick. Cool, Aaron. Let me know what you find. All right, nice. That's good. Feels pretty solid. And let's flip it over again. All right, so we're gonna tighten these up. Just gonna hand tighten them first. And then after hand tightening, we will we'll get out the pliers. At BPS.space. Okay, so use the engine paint that is rated to 1200 Fahrenheit. Is that like, I assume that's automotive, Arsenio, right? Okay. Nice. Pretty good hand tightening. We're gonna adjust sort of the angle of the flame trench. I mean, you can see it's not perfect. Like, it's a little loose here. But if you just sort of point it in the right direction and then tighten it, it'll stay. Have the feds showed up yet for selling guided missile tech? You know, they haven't. They haven't yet. No, actually, in all seriousness, it is going a little slower than I had hoped, but we are working with the, it's called the DDTC. DDTC is Directorate of Defense Trade Controls. That's it's a government agency, and so they manage the ITAR or the USML. So that's the International Traffic in Arms Regulations or the United States Munitions List. And those are the things that if they are defined in that document, you can't ship it outside of the U.S. without having a lot of trouble. And so they are reviewing Signal specifically to see if it falls under that category. And the process takes some time. You know, they have to talk to a lot of folks, and but that's like the right way to do it. So the feds did not show up at my door. I showed up at their door and said, "Look what I'm doing. Please help." And despite all the memes, they're really friendly and they are very helpful. So, okay. Wee woo, B-star, flamethrower. Okay. So this feels pretty good. I'm gonna give one more round of tightening and then we'll move the launch clamps. Okay. What else is everyone doing? I don't know what's going on right now. We got 44 people in the chat room. All 44 of you. Use your fingers and tell me what's going on. Why have you chosen to donate your time to this bizarre live stream where I'm just tightening bolts? Okay. Now we move the launch clamps. I'm going to go ahead and close them manually. Oh, this is a great opportunity to explain how the launch clamps work. These are actually getting a big old revision pretty soon. They work just fine, but they're like not safe enough yet. You know, a lot of the reasons that this stuff doesn't get published immediately for either being open source or put on some type of market is because it needs to be tested super rigorously. So like, these are just not reliable enough for consumer use yet. Anyway, let's open these two up and move them in. Oh, hold on. The first step, I forgot, it's a little complicated. The first step is the cover needs to be unscrewed. Okie doke. Man, raise your hand if you were here for the one time that Siri called me Big Papa. I just remembered that. I know Ben and Arsenio were. Johnny says, "Joe, come to Farm Boy." Wait, what is happening? Okay, chat, I need you all to type Joe come to Farnborough. So Ben is organizing this. Ben, okay, just I kind of assume everyone is familiar, but in case you are not, and you're in the stream, Ben C with the little guy next to him, the little wrench. He's a mod in the chat, and he is the guy who basically runs the Flame Trench, theflametrench.com, and it's a group of rocketry folks, and he's doing a meetup in the spring, and I am not going because tickets are really expensive for aircraft across the ocean. Anyway, that's what he's trying to get me to do. And if y'all pay for it, I'll go, but I don't think that's realistic. Okay. I like rockets. I just finished a Wino shooting gallery. Or Duino shoot, I don't know how that works. Big Papa. Alright, honestly I was waiting for EJ to start his stream, but then I noticed it's Tuesday. I need my daily dose. Hi Lauren, well welcome to the stream. I'm glad I could be your Eric Johnson replacement. Alright, I love the complexity of all the stuff you're doing. I thought I'd listen for a while when I built stuff. That's cool. Here we go. Clamp 1. So first we've got to take off the hood for the clamp mechanics. So there we go. This is what's inside. Woo! It's dusty in there, man. There's some rocket dust in that thing. So this is the launch clamp. This is what the mechanics actually look like. It's a little hard to see from the top down, but basically you've got a couple of different linkages. The 9-gram servo pushes the load-bearing member back and forth. It rotates along this thing, this guy right here in the middle, and then on the side, as this moves forward, this member right here pulls the clamp hood over the clamp. So I can I'll start it up again, and you'll see how they open and close. Hold on, let me do that one more time. So you can look at both of them at the same time and sort of see how this works. Can everyone see that? Is that somewhat clear? All right, that's clear enough. Whatever. So you can see it opens and closes. There we go. That's a pretty good view of it. Anyway, all right, so we need to unsecure this. We're going to do it with a screwdriver because it's a little tough for the drill. Okay. Carbon buildup. You should make liquid rockets. No, I should not. That's not a good idea for Joey B. That's when the feds do show up. Okay, there's one. These are long screws. These should be replaced. They're stainless steel, but they still rust a little bit. And so the corrosion means that if you are not careful, the head of the screw will eventually wear out in a really bad way, which means you cannot unscrew it. And we don't want that. Oh man, hold on. There it is. Okay, the clamp is released. There it goes. So this is it. This is a launch clamp. There you go. And everything catches on fire. Joe, just get everything anodized. I wanted to. I tried to. Actually, a bunch of parts from McMaster just came in the mail today. A bunch of screws to ship out with Signal for the orders, and I was looking to see if we could get black anodized hardware, but it's not available in the sizes that I want, and I wasn't going to try to spend a bunch of time on it. Okay. Anyway, so this clamp. See these holes? These 4 holes right here. This clamp moves in to where these 3 holes are. And the spacing is all already done out, so all you have to do is just move it. And I'm going to replace the screws with brand new ones right now. Okay, I've missed some chat. In Washington State, there was a big statewide launch. A college team had come down and launched. It was 11 feet tall. Could you see? That's cool. Where am I from? I'm in Nashville. I'm from Texas, technically, but I grew up in Massachusetts, and now I'm in Nashville. Where are the big ones? Aha! Shot in the dark. Maryland? In Tennessee now. Okay. Where is the chip R2 made? Here, I make it. I build it myself. And actually, we will eventually outsource the production of like the Sigma R2 computer. But while quality is still, how do I say this? Quality is still like making sure that everyone gets a really well working product is still a total priority. And there's just too high of a chance right now that I would screw something up sending it to a production house. So I'm doing them all myself. Okay. What kind of fuel is used? It's black powder. And it's all commercial bought. Don't make your own motors unless you know what you're doing. Say that again. Don't make your own motors unless you have a mentor or know what you're doing. People blow themselves up all the time. Okay. Hold on, sorry. You should move to Hawthorne so you can be closer to your companies. Ah ha 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 ha. Thank you. All right, hold on. Let's screw this in. Nice. Okay, there's one. Joe, you are my mentor. Oh man. Well, don't look to me for making motors because I don't know how to do it. Oh, I did that wrong. Hold on. Everyone say it at the same time. Joey B, do not answer chat and modify launch clamps at the same time. It's a bad idea. Okay, that will work. Nice. Do I sleep on a couch? What? No, I have a bed. Yeah, the no motor discussions, that's in the rules. The rules that we don't post anywhere. The board is... Joey B, do not answer chat and modify launch clamps at the same time. Is it a bad idea? Well, thanks, Mr. Steven. All right, here we go. This goes here. Nice. Very solid. And number 3. Bingo. Bingo, bango, bongo. Make my own... Okay, I'm serious. Katie Sutton, we're going to ban you if you keep talking about making your own motors. That's a serious hard rule. I listened to this podcast called Arms Control Wonk, and Arsenio knows what I'm talking about. But people kill themselves all the time, even when they know what they're doing making motors. And just don't do it. Just don't do it. Unless you know what you're doing. Okay. So, what I was saying is, Arsenio, did you listen to Bingo Fango, Mr. Steven, Bingo Bango Banga Bandu? How do you, Banga Bandu, Banga Danga Danga Danga. That's what Tim, the everyday astronaut, calls it. we met up and he was trying to pronounce Banga, I can't even pronounce it, Banga Bandu? Is that what it is? And you just called it banga banga danga danga. All right. Now, put these back on. Secure the... Oh, the first thing to secure is... Wait, this isn't right. Is this correct? Hold on. What is going on here? This should be screwed in. Who's running quality control around here? There we go. Let's, there we go. You can see that a little bit better. This was a little bit unscrewed, huh? That's no good. Okay, uno momento. What happens if someone talks about if it is their job? All right, stop. Stop with the motor stuff. I'm not kidding. Don't push it. All right. And I don't care if you're just curious. There are other discussion forums to talk about motors. I don't know why it devolves into this every time. So we're going to put the launch hood back on. And we need to, okay, I'm going to actually rotate this. So I can get a better view. This is a tricky part. This is another one of these things that's like, this is fine if you're building it yourself and not fine if you're trying to have someone else build it, because it's really, like, the way that the clamp has to be put together is just inefficient right now. Let's see, is that the right size? No, that's not the right size. You need this size. And the regular manual screwdriver. Oops, sorry guys. Listen, if I forget to move the camera, just like scream camera in the chat. All right. Someone's sending me memes. Okay. And there we go. Arsenio, stop sending me memes. Good, it's good, but not during the stream. Okay, everyone, someone talk to me about something else so that I can get off this subject. So we're putting back the launch clamp hood. You can see, like, this is just not an easy process. It has to all be, like, weirdly aligned, and so this is something that needs to be fixed. Okay, there we go. So first, the hood gets attached to the like articulating arm so that the hood can move up and down like this. And it has to really be done with the screwdriver because all of these other clamps are in the way of the drill. And we should be pretty much there. Yeah, all right, it's all tight. So now it moves the right way. Okay, that's all well and good. Now these guys get screwed in. There we go. Where's Grimes? Good one. Okay. How does the main rocket get separated from the other two, the heavy vehicle? JNSTNLR, lovely name, really lovely. If you ask that again, sorry, this sounds like I'm scolding it. If you ask that again, but like in 10 minutes or 15 minutes when this is done, I'll take the heavy vehicle out and we'll like explain it on the workbench. But yes, I can certainly cover that. Gun barrel bluing might solve your oxidation issue. Interesting. I'll look into that. Okay. T-minus 15 minutes. Okay. Good meme, Chase. Good meme indeed. Here we go. Let's put the rear screws back onto the launch clamp here. These have to be manually screwed in too. Well, actually, we can probably get a good deal of the way with the drill. It just scrapes against the pad. And there we go, right here. Nice. That's a little strip there. You can see it just slid right in. Okay. Next is the other clamp, which is right here. Sorry about all the noise. What's going on? Someone's leaving. Time to duck out of the stream, my dudes. See ya, Ben. Oh, wait, no, that's Johnny. Bye, Johnny. Have an awesome rest of your day. Goodbye, Johnny. Good luck with all of the math that you are currently doing. Johnny is the king of guidance for fuel optimal landing diverts. Okay. Did I already remove this? Wow, maybe I am having a stroke. One of these screws is already removed. I don't even remember doing it. Okay, 1. And 2. But these are all rusted. Or oxidized. Okay. Do I use explosive bolts for staging? No, I do not, because it doesn't make sense at this scale, really. But also because it's just way simpler to have it passively staged through differential thrust. Different thrust. Differential is like a fancy way of saying it, but... Okay, there's 1. There's 2. And this is going to be a tough one. Nice. Okay. Ooh, ouch! Oh my god! It's so hot! Who knew that materials heat up when they are put under stress? Who knew? Okay, clamp removed. Bingo. So we got some more questions. Do I have... Oh, hold on. Joe always looks like that it's... What? Face arm screw times? What is happening? I don't even know what anyone's talking about here. Do I have a Discord for BPS? Wow, what a fantastic segue into me talking about my Patreon page. Yes, I have a Discord for BPS. If you would like to join it, there's lots of information about rockets in there, and sometimes we chat about stuff, and people share cool stuff. Anyway, patreon.com/ It's either BPS.space or... I think I changed it. Yeah, I did. Okay. Patreon.com/ BPS_space. And if one of the mods wants to post it. Anyway, but yes, BPS does have a Discord, and there's all kinds of stuff in there. Okay. Why did the main engine so unstable? Okay, so so the rocket has to make decisions about where it wants to go, right? I'm going to try to explain this in like just a general way. And so some of this will be wrong, but it makes the whole explanation a lot simpler. So the rocket has to make decisions. Here's a rocket computer, right? This is signal. So let's say the rocket wants to move this way. It wants to turn this way, right? You want to make that well, here's what we should do. Let's say the rocket wants to move this way. It wants to turn to what is my left. It wants to rotate that way. So it has to push a little thrust vector amount down here this way so that it rotates like that. Right now, if the rocket, it wants to just go this way generally. But what happens if the rocket rolls a little bit? Now, you can't just like tell the rocket to do the same maneuver as before in the TBC mount, because now the mount has rotated as well. So the rocket has to track two different types of like reference frames. It tracks what we refer to as the global frame, and that's what the viewer looks at. So that's no matter what role or no matter what orientation the rocket is, it's like I always want to go that way. And like you can't rely on having roll control to any. Okay, anyway, so then the other frame is called the body frame. This is the local frame. And so this is what the rocket how the rocket understands itself to be facing. And so these two things, like if you want to go positive in the y direction. Anyway, whatever. There's a lot of math that happens to convert between these two frames, and the conversion has to happen for every control loop. Where like, boy, this is so hard to describe. Where the rocket understands where it wants to be going and then has to translate into like this other frame of what the rocket is actually doing and where it's actually facing. So there's a bunch of math that happens there, and there's a bunch of sort of initialization math that happens there too, where the rocket gets set up for what is 0, like what is the correct heading to be trying to point towards, right? Sorry. If you're under 16, get your parents' permission before logging on to BPS.space. Okay, sorry. It's a good meme, Ben. Anyway, so at launch, a lot of these things are taken care of, right? We sort of assume that the vehicle never has roll at liftoff. We assume that the roll of the vehicle is always 0. But we look at the x and y axes to determine, like, okay, our vehicle is starting off from this orientation, which means it's 20 degrees on the y-axis, 10 degrees on the x-axis, just as an example. And then 0 degrees on the z-axis, which represents the roll of the vehicle. Now, that is all well and good when you start vectoring on the pad, because then you like set all these things at 0 and they are all basically consistent with where they need to be. However, there's a roll program on the Falcon Heavy. So between the time that the center core lifts off and the time that the center core starts guidance, there's a little bit that changes. And specifically, there's 20 degrees on the z-axis that changes. So what's happening in the center core, the reason that it doesn't stabilize itself well, is that it lifts off the pad, it rolls, and this is not exactly how it happens, but you can think of it like the rocket does not know that it has rolled. The center core did not know that it had rolled. The data obviously shows that it had rolled, but sorry, if anyone's getting bored, you can just like log off and log on to BPS.space. We're almost done though. We're nearing the conclusion. So the rocket sort of thinks it hasn't rolled even though it has, which means that it is making decisions 20 degrees off of where it should be. So let's say the vehicle starts pointing this way, but it's actually making a correction this way. It's like, so you can see how it would sort of induce this like spiral. And if you look back at the Falcon Heavy launch footage, if you look back at the center core, that's exactly what it's doing. It's spiraling. That motor is sloshing around in this sort of formation because it's constantly chasing where it's trying to correct because it's 20 degrees off. Anyway, the solution is very simple. It's just a couple of software updates. But it's like, these are, there are so many things that can go wrong in a rocket launch. And as far as like this goes, this is a pretty harmless error because it's just a model rocket. But anyway, yeah, that is how it works. I'd be happy to explain it several more times so I can just like make it a simpler explanation. But anyway, there you go. Let me read some more questions and we'll get back into it. Oh man, I have missed so many things. We're just gonna try to slam through them here. Okay. Am I ever going to attempt a propulsive landing again? Yes, soon. I answered this question in a comment on the Falcon Heavy video recently, where basically I told the person who had asked a similar question, I have thought for the last 2 years that I would be able to land a model rocket within the next 3 months or next 2 months or something. This is like when Elon consistently said Falcon Heavy is going to be ready in 6 months. But it's like a sliding deadline of the next 3 months. So I'm convinced right now that I'll be able to land a model rocket or get a couple good attempts within 3 months. But if history tells us anything, it's that I have no idea. I'm going to keep working towards it. It's a little bit like climbing a mountain in the fog. You don't actually know where the top is. You know you're going up. I'm getting closer, but I don't know when. Sorry. Okay, here we go. Why was the center core engine and the side boosters? Was the center core engine different from the side boosters for Falcon Heavy? Nope, same motor. I want to donate. Is there an age requirement? I think that's the 16. Juicy maths. You should totally do a write-up of this. I think I will. I would love if our school taught this math in school. It's a little tricky, and it's really hard to get people interested in it too, because if you're not directly applying it, it's like, why are we learning this? Which is valid. I mean, it's really helpful for learning to just show exactly where it applies. Joe is a special brand of crazy, and apparently also has strokes. Oh my god. Sorry, we're almost there. I got confused. Kalman filters when your TBC sloshes around. What's up, says Lucas Zimmerman. What up? That's right. That's correct. Vape niche. I need to relearn matrix transformations, so the real Elon calendar applies to... I can't wait to see the attempts. See ya, I'm off to work on my L1. Bye, Chase. Heads up if... I think you either have rust or servo dust on your forehead. For real? Uh-oh. Take a little selfie camera here. Let's take a look. What's the... I don't actually know what the Lion King words are for that. But they like smear the thing on his forehead. Okay. This is out of control. I'm so sorry. If you're watching this and you were hoping for something like, legitimately educational or something like that, I really apologize. Okay. The first batch of R2s is shipping soon. Yes, it is. These hobby rockets is pretty harmless. Fast first test of MRC. Jared, what is MRC? I don't know what MRC is. How do you will reignite with an igniter? I wonder why the last stream took 9 hours. Did you watch? Because it's just a bunch of PCB building. I think we're gonna do another one of those PCB streams again. Raise your hand if you would be interested. Give me a big thumbs down. Not on the video, just like in the chat if you're not interested. If you thumbs down the video, you will regret it. No, you won't. Do what you want, but don't thumbs down the video. Okay, we need to secure this onto the pad because we've made no progress in like the last 20 minutes. So here we go. Okay, that feels pretty solid. You know what we should check? I know what we should check. Does everyone know what we should check? I'll show you. We need a fit check. Because what if it doesn't fit? Where's all my stuff? Okay. That's what we need. Low gang. Ah! No low gangers allowed here. Jake Paulers only. Here we go. Yep, that feels pretty solid. This could probably use a little tightening. Sometimes the reason I test that is sometimes there are slight inconsistencies in the way that the mount is in the way that the launch clamps are actually secured to the base. Like sometimes they pop up a little bit. So it's helpful to do a fit check while you are putting the clamps together. Oh yeah, that's rock solid. That's great. Okay. Solder techniques demonstrated were very good. I feel like that is perhaps sarcasm. But thank you if it's not. Really, really, thank you very much. Okay, we got a bunch of thumbs down. Model rocket computer. Oh, model rocket controller. Should be model rocket launcher. We got a thumbs up. Mr. Steven giving us a thumbs up. JR Craft. A big old thumbs down. Ouch. It hurts. Thumbs down like it's a Logan Paul. Oh man, I can't do this. I can't be hating on other YouTubers on my stream. Every time Joe starts a stream, he slowly goes insane. Yes, correct. His sensors are operating in low gang mode. This is awful. This is out of control. If Joey B does a stream and he doesn't lose his mind during it, did he really stream at all? These are the real questions. But he doesn't wash his board. You don't need to wash your boards! You don't need to do it, Arsenio. That was never the problem. Washing the board was never the issue. You were upset that I didn't do it, and the board also happened to be broken. But washing it wouldn't have fixed it. Heat gun technique. With that ex-Disney Channel flow. Joe, can we meet Bigger Papa next stream? Bigger Papa is in Massachusetts, where I used to live. So I'm afraid he won't be down in Nashville for a while. Sounds like Sputnik 2, simply everything just had to fit together on the spot. I have an idea. Since someone referenced you as Discount Elon, you should fly a Honda Civic on your cheap Falcon Heavy model. That is a good idea. Okay, someone's going to ship me a barrel of isopropyl alcohol. Thank you very much for the isopropyl alcohol. All of my boards will be so clean from now on. Very nice. Look at how shiny that is. Oh, it's pretty. Let's read them all. Let's redo them all. Thank you, McMastercar Bay. You know what's crazy? What's crazy? I order things from McMastercar. I ordered them last night at like 8. And they arrived like 4 hours ago. That's insane. That's insane. That's so fast. That's like Amazon times. Except it's a, machine supplier. Okay. Call it rooster heavy. Will one of your rockets land on Mars before Elon? Probably not. In every sense of how, no. The answer is no. Now everyone's just arguing about isopropyl alcohol. Arsenio also confirming that McMastercar is Bay. McMastercar is the one true Bay. And, oh, you know what? No, this should be new hardware too. Man, this is an uncomfortable way to hold the drill. I'm doing it, but it works for this and at this angle. Hold on. Reverse. Out of control. Okay, this is awful. There. Got it. JNSTNLR. I am so sorry. I cannot read German? Is that German? I think it's German. Here we go. Got it. Done. Bingo. Now we gotta wire it up again, which is like no work really. I thought he was referring. Oh my gosh. Hold on. When BPS is merch going to be released? Also, are there BPS parachutes going to be for sale? BPS merch coming this summer. It's going to be good. We're going to do some hats, I think. Maybe some shirts. Who knows? Yeah, it's just not a priority right now. We got to get Signal working real well, and then we'll sell some stuff. Okay, cool. Charlie, Mr. Charlie the Rocket Unicorn, suggests that I talk about the Launchpad upgrades that are perhaps coming. So why don't I do that? So we've got these electronic clamps right now. They're driven by 9-gram servos. And if you know anything about 9-gram servos, you know they're not extremely reliable. And so there is another solution that we came up with. And when I say we, it's probably worth noting, I am talking about Charlie and not really myself. Anyway, the solution is, what you do is it's hydraulic launch clamps. And so I'm going to have a hard time just describing this as it is, but you pressurize a bunch of aquarium tubing so that they all release at once as a function of the pressure in the tubing. Hold on, everyone close your ears. This is like not flush. There, nice. Anyway, yeah, hydraulic launch clamps are coming with either oil or water as their working fluid, but that's a little bit of a ways off. And do you know what hydraulic launch clamps also allow for? It means that your launch clamps won't short out when, hold on, which one is which here? Your launch clamps won't short out when you douse them in water, right? So water deluge system is maybe on the way as well. Gotta go, I'll be back in 30 minutes. Hope the pad comes together well. See ya, Aaron. Hold on. Try to say best. Candy Mountain Charlie. Aren't servos more reliable? I mean, not really. Like, the gear strip and especially the 9-gram servos are just super not reliable. Okay, cool. So, this guy is already connected. And we just need to connect to these. So we got 1 and 2, and the others should be unplugged. 1, 2, 3, 4. Ready? So it should only be 1, 2, 1, 2, 3, 4. These 4 clamps. Excellent. And there we go. So that's the pad conversion. That's how that works. So now there's only 1 flame trench with 2 outlets here. And yeah, that's what we got going on. So here's what I figure. I gotta go to the bathroom. I'm gonna do that. We're gonna take a quick intermission here, and then I'm gonna come back and we'll figure it out. Think of what you would like to see discussed, or if you're just sick of Joey B, I don't know, let me know. Tell me you're sick of me and to end the stream. We're going to an intermission. I'll talk to you in a few minutes. please go to this website. It's Joey B. I'm back. Hello, everyone. Welcome back to the stream. And let's go ahead and head over to the workbench. Oh, I didn't transition there. I'm in the wrong mode. Hold on. Let's go over to the workbench. Okay. There is dust all over this thing. I'm going to clean that up first. And now, my hands are sufficiently dirty. And look at that, now they're clean, just like that. All you gotta do is put them on your jeans. Okay, we're gonna look at the Falcon Heavy. So, we'll start with the center core. I'm wondering how much of this will show up clearly in the frame. And I'm not quite sure how much actually will, but we'll see. And then we got a side booster. This one's going right here. And this one is going right here. Boom, just like that. Okay. Yes, Ben is right. Ben is heading out. Go to theflametrench.com and sign up for the email list. This is the best stream I've seen in my whole dang life. Wow, thank you, Mr. Steven. What a kind compliment that you came up with. That's so wonderful that you came up with that, and that didn't see any type of suggestion for you to do that type of comment. Okay. Thanks, Joe. Got to charge less coffee. We need a wider fisheye lens camera. Please explain how the separation worked. You got it. I remembered. Well, I didn't remember so much as you reminded me. Here's how it works. So, how am I going to do this? I need more table space. Do you think I can move this soldering iron? Maybe I'll just do that. Okay, let's just move the soldering iron. Oh, that's a nightmare. I really don't want to do that. Let's tilt the camera just a little bit. So now you can see a good portion of the rocket. Boy, just not quite enough of it though. Well, we'll look at the bottom first. That's what we'll do. We'll sort of do it in sections. So on the bottom of the rocket, these are all the cores as they are usually organized. We can sort of explain what's going on here. We've got, hold on, this light is a little bit out of control. So SpaceX has the Octaweb, right? The Octaweb is the thing that holds the 9 Merlin engines into the bottom of the rocket. It takes the load of the vehicle. It has a bunch of avionics inside, I think, and a whole bunch of other stuff. Anyway, this is not the same thing, but it is sort of similar. The Octaweb has a lot of pad interfaces and sort of structural elements to it, and so that is what this thing right here is. This is actually sort of an isolated version. I don't have a good name for it, but it's basically, it's the thing that holds the landing legs, it's the thing that interfaces with the rocket, it's the thing that protects the rocket when it hits the ground, and then it also interfaces with the launch clamps too, so that the clamps can hold the rocket onto the ground. Anyway, this thing has a couple of holes in the bottom of it. You can sort of see them here, right? Around each corner there are 2 holes. And then the other thing that we have, whoops, hold on. Let me see if I can find it. On each side core, we have this little piece right here with little spikes on it, right? And so the spikes, for the side cores to be attached to the bottom of the rocket, the spikes fit right into these holes so that they can put force into the bottom of the center core right here. So if I were to attach this core right now, all I'd have to do, I don't know how well you can see this, oops. Where am I going here? There it is. So right here, you see the spikes on there? It's just attached via 2 screws. And so this just slides into the center core. And now, like any force that's applied into the bottom of the side core here is also applied into the center core. But of course, if the center core comes up to thrust at all, it just pushes off because it is passively mounted on there. Does that make sense? So as long as the center core has less thrust, which can be 0, but less thrust than the side cores, the center core will stay attached. And so this works in both ways. Basically, it works with both cores. And then the other thing, right, because you can't just have it on the bottom, it has to be on the top as well. The top interface is a little bit different. And we're going to scoot on down the vehicle here. So the top interface is a little bit different, right? So this is the top. This is the top of the center core, or this is the sort of intercore interface. And the side cores have these sort of screw points, like screw-based mounting points. And so there are holes in the top of this interface here, so that at the same time that you're sliding that bottom plate into the center core, you're also sliding these things into the top of the center core. So, hold on, I'm doing a bad job of this. Like that. So now they are attached, right? The cores are attached. Actually, the bottom isn't attached, but now it is. Okay, so this is a fully attached thing, and as long as I move the right core, or the left core really, but as long as I move that, it moves the center core with it. And if I roll the right core, well, they can't detach the bottom, it's quite delicate, but if I were to roll the right core, it picks the center core up with it, because it's like a rigid enough attachment that it's not, that bad. And then the other thing that can happen here, we'll just sort of talk about one more thing. The other thing that is good about this setup is you can secure it. So, 1 minute. I'm just going to do this with one screw because it will be sufficient. So here's a little nut, right? This is a little tiny nut that can go onto the screw. So I'm going to go ahead and attach that. There's a little bit of the screw from the side booster that peeks out the top of the intercore interface in the center core. And so if I tighten that down, now, oh, hold on. I shouldn't have done that because the bottom of the core wasn't attached. So let me go ahead and undo that, back it out just a little bit, and then reattach it. Excellent. So now I'm going to put the nut back on the screw here, and hold on, screw it down, just going to sort of finger tighten it, and now they are attached. They are fully attached. I can move it anyway with the center core or with the side core, and it can't come apart. So this is really helpful for transport. Like, this is what happens when I put the vehicle in my car, bring it out to the pad, etc. But as soon as I detach this, and it's just this one nut that's holding it on right now, right? That's all it really takes. As soon as I detach that, boom, it can detach. So that is how separation works. And of course, this works with 2 cores on it as well, but I'm just demonstrating with one for simplicity. So I've missed a bunch of chat, and I've got rockets everywhere. Hold on. Let's look. What do we got here? Please explain how separation worked. Right, got that. Are the skirts on the bottom of the rocket 3D printed? Yes, they are. When the engine shut off, the stage falls away due to drag and other forces like gravity. Not really. Kind of, but drag is like pretty insignificant. So the stage really falls off because of the thrust in the center core. Uniweb, monoweb. That's really clever. Thanks, Will. Why not make the interstate black? I think you mean interstage. Well, because I didn't really care about it. I was more concerned with the software and getting it to fly well. Thank you. You mean raceway? There's no raceways on these rockets. Yeah. Okay, are those bits on the interstage slopped like that as the screws come out to make the side... Oh, sloped, yes! Weatherworld asks, am I going to land a rocket using propulsion eventually? Eventually, yes. Someone asked, Will asked, another question that I would love to answer right now. Okay. this is one of the things that I'm like most proud of. So the center core attachment point has these little slopes on it. You see these, right? It's like a little, you know, and when the side core is mounted, right, that doesn't really matter. But as soon as the side core falls off, the slopes push it away. Go back and watch the Falcon Heavy video. Watch like the super slow motion tracking camera. When the cores come off, they actually get pushed away from the vehicle a little bit because the slopes just give them a little bit of, right? Just a little bit of a push. It's really not significant. Like, it's pretty tiny, but it does help the boosters clear the center core, which is really important. You really want, like, as soon as those boosters are done, they need to be out of the way. Okay. I think we're all caught up on the chat. Uh-oh. Well, there goes that thing on the floor. Anyway, so that is how the Falcon Heavy staging system works. And then for the second stage, which I'll go get now. Hold on one second. So this is really just, I mean, this is mostly just a tube, but this is the second stage. And so the second stage gets attached to the top of the center core, and it separates by just lighting the motor in the second stage, which we're going to have to do a little bit of fancy engineering here, but it's going to push a bunch of exhaust into the center core to separate itself. It doesn't really pressurize the center core because there's a lot of venting going on here, but it's more about, once again, it's about the stage that is being transitioned to separates by just coming up to thrust. It's pretty simple. It's used in some real rockets, and there are definitely like better ways to do it, but there's basically like no simpler way to do it. Yeah, so that's how it works. I think we're all caught up on the chat. You should add Moonlander style landing legs to the second stage. This thing is already so heavy. I don't know if I can afford any extra weight on the vehicle right now. I had to take the landing legs off of the center core just to make that recent flight that we had. When the actual heavy vehicle launches, it's going to, we're going to actually have the center core be pushing as well while the vehicle goes up, just like the actual Falcon Heavy. Okay, Arsenio says, I'm on station for like another hour, then commute home. Well, I think that's about all I wanted to do today. I fixed the Launchpad a little bit, talked about the Falcon Heavy a bit. If anyone has any other questions, we can go through them. But otherwise, how heavy is it? It's like, actually, I mean, it really depends on the payload. Actually, speaking of payloads, we are flying a payload soon. Sam, I don't know if you're watching. If you are, hello, sir. But my buddy Sam from, well, I don't know if I can actually say. Anyway, my buddy Sam is working on guided recovery via parafoils in high-power rockets. And we're going to start flying payloads for him, which is, he's building a flight computer, so we're going to start flying payloads for him in, I think Thrusty McThrust-Space back there is going to fly some, and then we'll fly some on some smaller rockets too, but he's basically just looking for flight data. Anyway, I spoke about payloads, and they're coming. It's going to be cool. What if the motor for the second stage also slide into a small plunger kind of deal for Seco? Huh. Can you, Mr. Steven, can you elaborate on what you mean by that? How long does printing one of those stands take? One of the stands. Let's see. Will, can you elaborate on that too? Do you mean like the Launchpad? Or do you mean... A leg print, let's see, printing one leg is about 2 hours. Printing the mono web is like another 2 hours. Printing the launch clamps is like 3 hours per clamp. What else is a lot? I mean, it's a lot of printing to get all this stuff to work. For the rocket stand, a few hours. Yeah, for the actual Launchpad, it was like a full week and a half of printing to get all of the parts to come out in good quality. As in one of the gray bits that's holding. Oh, this the rocket cradle, the BPS rocket cradle. This one takes, I don't know. You could probably do it in 2 hours, maybe an hour if you're crazy with your print speed. But yes, Thingiverse. Go look up the BPS rocket cradle. It's super helpful. I'm serious. Like it for real is like how I work on all of my rockets, and it's free. So. Okay, what printer do I use and what nozzle size? The nozzle size is I think it's 0.4 millimeters. I don't know. I use the Monoprice Maker Select, but I think I'm going to be doing another live stream where I assemble a Prusa printer, and that's the Prusa i3 Mark II. I think that's what it is. I still haven't set it up yet. Are you eventually going to sell printed parts? I might. It's easier for people to print them on their own if they have a printer, but I might, Signal Alpha comes, or Signal R2 comes with parts that I 3D printed. Make a drone ship. The Monoprice i3. If stock, if it's stock. Hey Eric, what's up? It's nice to see you. Well, it's nice to hear you in the chat. The stock is definitely 0.4 millimeters, not an M3. No, it's not the Mark III. It's the, hold on. The Prusa is the Mark II. The Monoprice is the i3, which is the Maker Select V2. So they're both V2, basically. I did not buy the newest Prusa. I bought, like, the previous revision. Do we have any other questions? And if not, I have to go grocery shopping. I'm going to be making this week, folks. I'm going to be making, it's a lemon, like, chicken, beautiful medley of flavor that you put in the crock pot for like 8 hours. And it's just so good. And it's not healthy. And I don't care. It's beautiful. It's really nice. And if no one has any other questions, I'm just going to talk about my week meal plan for a little bit, and then I'm going to log off. Oh boy. Mr. Steven says, I'll tweet you a drawing of the whole Tube Seco thing. Cool. Joe, let me introduce you to one of my favorite sites. Gonna sleep now. It's midnight in Germany. Good night, JNSTNLR. Some cool stuff. Last break. SeriousEats.com. Do not read while hungry. I'm a little hungry. Oh, look, food site. All right, well, folks, listen. Oh, Will Trent. Hi, Will Trent. And indeed, he did like my post. I would love to see more PCB building streams. Excellent. We've got some coming up. What maintenance do I do after every launch? I clean the launch pad. That pad looks a lot better than it did. Let me see if I can bring up a photo here. Okay, I wonder if this will display well. But after launch, this is what the pad looks like. Like just covered in soot. So after launch, it's important to just like clean it off and make sure it's all ready to go and do a bunch of checks. And then on the rocket, I mean, really nothing. You change the pyro charges and then you change the motor and you're all good to go. And you charge the battery. Turn the rocket on too, that might be kind of cool. We could do a little signal demo. Here we go. Hold on, let me do that again so everyone can see. Boom. Let's look at, let's do a little signal stuff here. So here's our computer. You can see we got some live readings. Oh, it says upside down for everyone, sorry. We got some live readings. This is the live gyroscope stuff. If I wanted to, I could calibrate the gyroscope. And it's just going to read a bunch of readings here and then take the average. Cool. We got the same for accelerometers. We've got our temperature, pressure, IMU temperature, the system voltage. What else we got? Pyro control. it's showing continuity on Pyro Channel 2 because the igniters that I use for the parachutes, they retain their continuity after they are burned. So there's actually nothing connected there. But to demonstrate this is on Pyro Channel 3 right here. There's a bunch of connectors on this rocket, and look at that. It shows up. Isn't that cool? And then with pyro testing too, you can actually fire the pyros. I'm not going to be doing that. You arm them and then hit fire, but we're not doing that today. What else? We got thrust vectoring. I think I've talked about this before in a video. Oh look, I put up a little system preps thing so that you can test a few different functions on the computer. Hold on, which way is the right way for the phone? I think this is it. Now we're going to slide it in like that. Okay, here we go. So we got a little LED test, which blinks all the LEDs a bunch, and then a buzzer test. You can also turn the buzzer off if you want. Oh, hold on. There we go. Isn't that cool? I love that. And then you can do a full system reset if you want to, in case anything goes super wrong. Anyway, that's Signal. It's kind of just something fun to show. Party mode. Were you going to show the footage of the camera inside the Launchpad? I could do that. Is the gimbal open source? It is not. The gimbal is closed source. If you're going to make a solid engine, what would be the composition? Do not ask Lucas about making your own motors. Perhaps you're new here. But anyway, I don't make my own motors, and I advocate that other people don't either, unless they are professionals actually working in the industry or have gone to school for it. So I teach myself a lot of stuff, right? Like I taught myself how to code and how to build model rockets and stuff like that. I mean, some of these things aren't that hard, but you should not be teaching yourself how to build your own motors without like a mentor or someone to help you, because you'll kill yourself. Like it's so dangerous to be testing your own motors, and unless you have really solid guidance on how to do it, it's just a really bad idea. And I totally cannot emphasize that enough. And so we don't allow chat in. Uh-oh. What happened here? There we go. So I don't know what happened here. We don't allow chat in. We don't allow chat about making your own motors. Anyway, yes. Noted during the FH launch, you had the boosters burning while on descent. Nice to see you tried to land them with the engines. They are burning, but they're not actually burning. So there's a delay grain, which is not actually producing a lot of thrust. And it looks like it's burning because we launch at dusk, but it's actually just like spitting out sparks. There's no appreciable thrust in there, but it does look cool. Okay, the motors aren't producing thrust. Oh yeah, Arsenio, Arsenio, I just listened to the ACW podcast about that. This is why I'm serious about the motors. Arsenio and I listened to this podcast on arms control and nuclear non-proliferation. And anyway, they were discussing Iran used to have this solid fuel program, and a bunch of like really smart scientists working on it, trying to build a solid fuel rocket, and then the rocket blew up and it killed the whole team. Like the whole entire engineering team was killed because they were making their own motors and they weren't careful with it. And they were smart. Like, anyway, whatever. I need to stop talking about motors. Folks, hold on. How long are the long burning motors that the company is making going? Are they becoming more reliable? Okay, so Aerotech, BPS is working with Aerotech to develop a long-burning solution for thrust vectoring, right? So most model rockets, I don't know. Almost everyone here has heard me go through the spiel of this, but most model rockets have really short burn times. This doesn't work well for thrust vectoring, so we're building a motor that works well for it. The next tests that are coming up are probably in a week or two. We've got a 10 Newton variant of the G8, so it's a G10, and it'll be plugged again. It'll be a lot of the same characteristics, except we have shortened the burn time to 12 seconds instead of 17, or well, our target is 12, but essentially you after a certain point, you just don't want to keep burning the motor. Like 17 seconds is great, but even small errors over 17 seconds really accumulate. So your flights become very unpredictable. And then you also, if you don't have roll control, it becomes a problem too. So that's why we decided to shorten the burn time, which should also help with the motor tube melting issue. Okay. Okay. Anyway, folks, thank you for tuning in. That's about all that I have. Unless anyone has any other questions, I'm going to call it a day. Thank you for joining me as we cleaned up the Launchpad, talked about Falcon Heavy a little bit. I think I'm going to be streaming later this week. We've got some PCBs to build. We've got some... I would like to do a live stream of the printer build. That's mostly going to be me messing things up and then reading instructions. And that's what's up. That's what's new. My name's Joey B. Thank you very much for watching, and I will talk to you all soon. And now, I have to end the stream with all this stuff on my desk. Okay, here we go. 3, 2, 1, goodbye.